So today in this webinar, it's primarily to talk about global industry 4.0 implementation challenges. We'll talk about what are those challenges and most importantly, how artificial intelligence and machine learning operations, which we also call MLOps, enable predictive maintenance solutions that are impacting the business efficiencies, how exactly these solutions impact the business efficiencies, also how it will help or support organizations with faster time to market and quick to implement intelligent solutions or enterprise solutions. Most importantly, with the 2x impact on product quality and customer experience. So that is the whole theme of this webinar. So that is you can expect in this webinar today. If we can just go to the next slide. Let me quickly introduce myself. Let me start with my introduction. My name is Dharmesh Raghav. I work in the capacity of Regional Vice President Digital Solutions with Communal Group. I have an experience of around 18 years working with global enterprises, primarily in North America and in Indian market and in European markets, and helping them modernize their IT infrastructure, selling IT services and products. So that is a brief introduction about myself. Let me quickly introduce Dr. Ravi as well. Dr. Ravi is our practice head for AI and emerging technologies at Communal Digital, and I'll allow Dr. Ravi to talk a little bit about himself.
Hello, everyone. So if I talk about my particular experiences in terms of working on different domains, I started my career a long time back in 2008, having 14 years plus of experience in terms of working with the clients in terms of AI ML solutions, especially building end-to-end pipelines for their predictive maintenance applications. Apart from that, worked with 17 different industries, right from banking to aerospace engineering, and help the companies to achieve the particular, help them to scale up their business activities, converting their particular, business to multi-billion dollar business, and help the corporates to attain the particular targets which they were, about to have within, let's say, a couple of years of time. So if I talk about the, the experiences, if you can go to the next slide, these were the clienteles which I served in the recent past. And talking about the Verizon Communications, Sign Technologies, I worked for aerospace engineering, Mercedes-Benz, help them to understand how exactly AI infrastructure would be helping their team to work on different predictive applications, especially when we talk about, the AI for automobiles. Michelin Tires, Reliance Retail, eClerks, Amdocs, Brazil, and there are a lot many players like that. So these are the key core players where exactly I was able to fix up their challenges and the issues regarding the MLOps activities. Apart from that, very closely we witnessed the workarounds at the World Bank Group. We're happy to share certain insights from different projects during the entire workshop so that we can understand how exactly we can help the industries to scale their particular, machine learning operations. And not only that, how AI in manufacturing and let's say in predictive maintenance would be suitable for business to have the optimum growth. So with that, I would like to go ahead further.
Thank you, Dr. Ravi, for the quick introduction. And let me talk a little bit about, or a quick introduction of Communal Group as well. So if I talk about Communal Group, Communal Group is almost a 3-decade young organization, I would say, founded in 1993 as a custom development shop when there were not many off-the-shelf product available and out there in the market. And from there, we had a journey to become an end-to-end IT consulting and IT services organization. Currently, we are serving more than 200 plus customers globally. Most of them are Fortune 500 organizations and also many large enterprises and mid-market organizations, and help them transform their digital journey while augmenting their prevailing capabilities. If I talk about our presence, we have 10 plus offices spread across United States, Canada, Europe, and we have multiple offshore delivery centers in India with a digital workforce of more than 4,500 people. During our journey, we have partnered with various leading product organizations to expand our delivery capabilities. Like we are Microsoft Gold partner, offering expertise across Microsoft technologies. We have partnership with AWS, Google, Automation Anywhere on the RPA front. We have various other platforms on the data side, like Prophecy, Snowflake, just to name a few. So instead of reinventing the wheel, we have partnered with the right organizations or product partners to to deliver those capabilities to our customers. So that is in a nutshell about Computer Group. So with this, I just want to move ahead from here. Dr. Ravi, if I talk about the key takeaways of on behalf of our audience, if I talk about the key takeaways from this webinar, what do you think? If you can just talk a little bit about the key takeaways of this webinar and what all things we'll be covering in this webinar to help our customers or to help our audience here. If you can just talk a little bit about that.
Sure, Dharmesh. Before that, if we can get one-liner introduction from the entire attendee side, would be helping us to orient the session further. I mean, we can understand how exactly we can, help them in the best manner when they attend this webinar. So the key takeaways, if you go to the slide where exactly we talk about, they would be able to understand how exactly we can optimize the predictive maintenance solutions. What exactly is the aspect when we cover up, let's say, the highly optimized area of proactive asset maintenance, especially when it is being powered by predictive intelligence. Apart from that, how we can definitely create certain self-evolving machine learning models, which was earlier, it was very difficult task, right? We'll discuss about the industry 4.0 as well, right? Where exactly we can get to know how digital transformation is taking place. And apart from that, automation in the industry aspects would be covered up in detailed manner. So apart from that, we can also discuss the intuitive Power BI application. So let's say it could be any apart from Power BI, it could be, let's say, Tableau applications. We can have different platforms today. So we'll be discussing almost all the platforms which are available for the entire end-to-end applications developments, right? So apart from that, we'll also be covering up IoT powered data collection. So that the key takeaway would be that how exactly we can have a better IIoT instead, like industrial IoT, that is the Internet of Things, and how exactly sensor technology would be helping the industries to scale up their predictive maintenance solutions. Apart from that, we'll be definitely talking about the MLOps, which will be further optimizing their entire business performance, right? Apart from that, happy to share what exactly the audience is here about. And for them, we would like to definitely, take those pointers as well. We'll also accommodate their questions as well, right? So to make it more interactive.
Great, thanks. Thanks, Dr. Ravi. And just to share it with the audience, please feel free to share your questions in the chat box. If you have any at any given point of time, we'll try to take them up as and when it will come. And Dr. Ravi, coming back to the points which you have just mentioned, you were talking about Industry 4.0. Let me start with this Industry 4.0 aspect and what according to you are the key ingredients of Industry 4.0, and what do you think are the key barriers or the major barriers when you talk about in this Industry 4.0 and the overall digital transformation journey? What are the key barriers which you see?
So Dharmesh, why not let's get into the Industry 3.0 first, right? So that we can pick it from there, and then we can even talk about, let's say, 4.0 and the 5.0. So I think everybody, like in the audience, everybody is aware that we were having certain revolutions, like we started from wheel to, let's say, industry, and then we went to agriculture. Even there were green revolutions and white revolutions as well, right, in the farming side. But coming to the industry side, third revolution was more on computer side, right? It was more towards computer science, the inventions and the discoveries out there, working on the algorithms, framework, etc. But the computing power were very, very, what we can say, less optimized. In that case, there was a dire need from the market that we should have a speedy network, we should have a particular internet, we should have the capabilities to scale up business activities by putting the databases over there and the cloud platform. So when I talk about when we talk about Industry 4.0, obviously the term has come from the German side, so that's industry instead of the industry which we used to have.
Yeah,
as per the World Economic. Yeah. Yes. So as per the World Economic Forum, the major aspects which we need to target here is number one, it is about soft computing. So when I talk about Industry 4.0, the revolution was earlier in terms of computer science. When it comes to the previous one, right? When it comes to 4.0, it's totally dependent on how exactly industry is ready for automation. And I don't know if the audience is aware that we already have Industry 5.0 as well in place, where exactly it is more towards cognitive science, working on robotics aspects, and how exactly we can have humanoids over there in place. Recently, we also were able to discover those particular developments from Tesla, right? So there are so many things which are coming up, but in this particular session, I would be focusing more towards 4.0. We are yet to achieve that at a global scale. So talking about automation first. So the dire need is to have automation. Why do we need automation? That's very pretty clear. We need to have a better business performance. The product quality has to be improvised. There are so many hazards in the factory environments where exactly humans cannot work in that scenarios, and it is affecting their health also badly. Not only that, when it comes to the efficiencies, when exactly it is a very difficult task to and a monotonous task, to operate. So therein we need certain machineries which can be further automated. We need to every time we cannot keep a track of n number of industrial equipments. At the same time, if it is done automatically, the bots are utilized such a way that machines can talk to machines. So why not to have those capabilities within, so that humans can focus more on the conscious side, the conscious side, and the machines can focus on the material aspects of it. So it is like matter dealing with matter and human concise dealing with the global challenges. So therefore, automation is very much ingredient of it. Apart from that, the big data practices, obviously, because of the advent of certain cloud platforms and let's say speedy internet, huge varieties of data sets, huge volume of data sets. So big data is already available with us to get accustomed to the industry 4.0 revolution. Apart from that, we have not mentioned even let's say the 3D computing and let's say the 3D printing side of it. Apart from that, digital twins and the metaverse platforms, we are not going to discuss in a very elaborative manner because we are also going to discuss certain things in our upcoming webinars. So in this particular webinar, we are focusing on cloud computing, how exactly we can work on autonomous systems, especially when we talk about forklifts or let's say the robots, which exactly deals with monotonous task. So I'll also discuss what are 3 different stages of artificial intelligence and at what level we are in the present scenario. And then IoT is another integral part of it. We cannot get devoid of IoT uses, and especially IIoT, that is Industrial Internet of Things. The reason being, it is making the things simpler when it comes to the physical maintenance and let's say the kind of evaluations of different assets. It is very difficult. So what exactly is happening is we are having better networking, better platforms like MQTT and all, which exactly works under a protocol, and it is very easy now to send information from a machine to a particular sensor and then to the mobile application or the web application. And in the end, data management. So this is very core element of it because we may ignore it, but the thing is like when we talk about the pain points of most of the industry experts, what they bring in on the table is like, hey, we are having the predictive maintenance of maturity level 3 or 4, even 5. But the thing is like that when it comes to the data usage, there are huge dimensions of data sets in one particular system. There is another system, subsystem, where the dimensions could be different. Bringing those multiple dimensions and then synchronizing the data set as per the requirement for analytics, it is very difficult. At the same time, it has to be automated. So there are the most of the challenges which we'll be talking about. And I would also request audience, to focus on those particular things. And if they have any queries, they can directly post it so I can take up those particular aspects in the discussion. So here we say that, these are the major ingredients. Apart from that, if we identify the other pain points, so let's say you said what a kind of challenges the industry is facing. So there you can see there are global challenges which we have identified. In the next slide, please. Yep. So here you can see that all those red flags are coming from industrial equipment side, right? The other things are like barriers to digital transformation, component digital already doing in such a way that we are actually practicing all those particular transformations, and even the companies with whom we are associated, they are also happily commenting that exactly the digital transformation in the current era is very much important, be it a robotic process automation kind of a framework, be it a automation, be it a particular aspect of let's say working on predictive maintenance side of it. The major barriers are the thought process of the management from the higher ups, and let's say at the same time the different thought process from the executives. So for example, if I talk about certain things which occurred in the recent past while working on some client projects, what exactly we came to know is like, hey, we are about to shift from Asian practice of our business to let's say European one, and we need to have better automation. But now, at the same time, what exactly the employees are resisting is they don't want to get accustomed to those techniques and technologies because it requires programmatical access. It requires enhancing the skills in terms of machine learning, data science, and whatnot. So those are the kind of aversions which are coming up that would be that is basically a major barrier to the digital transformation in place. Apart from that, we also get frequently the kind of scenarios where exactly clients say that, hey, we have got so many platforms, but how exactly we should select the vendors? It looks very simple when we talk about identifying, let's say, business opportunity with different vendors, and let's say who would be my appropriate supplier for this particular manufacturing. But in real time, there are so many complications to it that even the customers, let's say, the bargaining power of the vendors are more than those who are exactly at the buyer side. So in that case, vendor selection is one of the important criterion, which is exactly confronting so many challenges because of the reason that there are certain unorganized mechanisms which companies are using, especially in manufacturing, because certain sectors are really organized, certain sectors are not that organized. So therein they require attention. Vision issues are there in the organization. I told you that the higher ups, if they don't have the vision to automate, how exactly Industry 4.0 would be happening, and the lethargy from that sector definitely will be impeding the success of the entire organization as well. The major pain points again, we can definitely go for Industry 4.0, but is it really impacting the customer experience, right? Because most of the cases which we come across is like they are totally complex, making the things more complex than making them simple. So if I talk about a cloud platform for working on predictive maintenance solution, there would be data scientists who can claim that there are n number of ways by which they can complex the entire architecture. So the basic understanding on the increasing the customer experiences gets diluted. Moreover, it is more satisfying how exactly technically we are more sound. So therein we need to have a proper alignment between that. Apart from that, if I talk about the sustainability, yes, that sustainability is very global problem nowadays in terms of manufacturing units as well, because of the advent of different technologies and the infrastructures which are available. Wherein the red flags, if you can see, the industrial equipment failures, these are the critical areas to work upon, because that impedes the entire failure of Industry 4.0. Because if the particular your what we can say the equipments fail, how exactly you'll be keeping a particular timeline to meet the requirements of the globe, and especially the global customers, and with the appropriate timeliness. So in that case, the scheduling and everything would be affected. So in my viewpoint, these are some of the gray areas when we talk about how exactly uh, uh, the which needs the basic addressal from everybody, like be it from the service side, be it from the manufacturing side, everybody would be contributing at the same level. Apart from that, you can see industrial equipment failures. What are the reasons behind that? So there is a particular framework which you call it the predictive maintenance, right, which I discussed. So the PDM way basically addresses industrial equipment failures. But again, PDM itself has so many challenges today, right? So if I talk about industrial equipment failures, we have a solution in place that we can have predictive maintenance solutions, and it can counter attack all those particular failures. The mechanisms are already there, but itself it is suffering from the problems in understanding right data ops. Apart from that, you can see the second red flag would be working on, let's say, in terms of how exactly we can have the right vendor in place to work on different sensor technologies, or let's say the cloud platforms. The technical challenges are there. Apart from that, there are so many integration issues I discussed, right? Just before discussing all these pointers, that companies are facing the data dimensionality issues and the integration issues with different platforms. So now they are having multiple vendors. Managing them on the single cloud platform, or let's say on-prem platforms, would be really difficult for them. At the same time, the major challenge over here is business use case integration with the IT and technological departments workarounds. So there also is a gap. We'll discuss some crucial elements from the previous workarounds, and I think everybody would be understanding how exactly these things could be even better.
Yeah. So Dr. Ravi, just to for everybody's uh, best interest, let me put this question. You spoke about PDM way. So what exactly is predictive maintenance way, and why you think it is very important for the industry, and what is its relevance to Industry 4.0? So these are the very basic questions which comes to anybody's mind. If you can throw some light on that, and
Sure.
most importantly, if you can just also talk a little bit about what is the basic difference between predictive and preventive maintenance. So it'll help our audience to understand a little bit about that.
So as the name says, like, let me first of all give a background that what exactly is a predictive maintenance. So for example, if we are having a particular, just to make the audience very clear on this, so we may have definitely some household equipments or let's say some electrical products, right? So what if we are using a refrigerator and it fails all of a sudden, and at the same time we are going to have certain guests in our home. So what exactly it would be impacting the mesh in that case?
I'm sorry, you're posing it
For
to me.
example, we have a refrigerator in our home, and there were some guests which were planning a visit to our home, and all of a sudden it gets failed. And just imagine that it's like a summertime, right?
Yeah,
And
of
you
course.
don't have any alert. You
Yes,
were
yes,
not
of
sure
course.
that it will fail. At the
Yeah.
same time, you have to call a particular electrician or maybe a particular person who is technician for the refrigerator. But the whole thing is that at the same time, when your guests are there, the electricians are there, you are mugging up with n number of things how exactly you can serve in the best way. Same thing happen when we talk about, let's say, in the industrial scenario, when there is a huge demand in the market for your product. Would you really be bothering yourself by putting those kind of electricians, let's say fitters or whosoever is required, to just fix up those machinery issues, right? So in
Yes,
that
yes,
case,
that's
what we
right.
should have is we should have a alert mechanism that, hey, at this particular moment, I should have a particular maintenance of my machine. The machine requires a kind of a replacement. The machine requires a kind of a lubricant even. The machine requires, let's say, even a better supply of the power. So in that case, what exactly is happening is we are having a system in place which exactly beforehand identify with different modes. Like you can see that we are talking about different modes of machinery outputs. Like it could be vibration, the pressure, the temperature of machine. So those kind of things we need to identify. So consider that particular machine is nothing else but a patient for you, and you have to diagnose that patient with disease. So would you really be waiting for that patient that he gets into the emergency only, then only we'll be treating? So
Of
before
course not.
then, we
Of
should
course not.
have the regular health checkups, and regular health checkups are there. But the thing is, the predictive maintenance give it a power that we can even diagnose what exactly would be the situation with that given machine after a week's time, after a month's time. So therein we can take the appropriate measures. Seeking the particular, supplier when the machine gets failed will be obviously increasing the bargaining power of the supplier himself, right? They know that it's an emergency for you, and definitely they can charge you more, and no credit periods. So likewise, you can best optimize your operating cycles, the credit policies that your debtors, your creditors, the cash in and cash at bank, everything is being synchronized once your assets, the fixed assets are in place. So it could be fixed assets, it could be current assets. But yes, when you talk about machinery and all, they basically are a part of your fixed asset, which is long-term investment. And why to bother yourself when exactly we are utilizing them? Why not to keep them under scrutiny, under monitoring? That's what exactly predictive maintenance does. It gets into anomaly detection, it gets into diagnostics, and it gets into the predictions. So we can even estimate what it would be the lifetime of that machine. Most of the financial counterparts, let's say professionals, what they do is they go for the buying out decisions of a machine, like when it's a big equipment for you. So they plan it out like how exactly I should have the purchase. It would be a kind of a the entire replacement of the asset, or it would be just a maintenance would do, or it could be something like I can get on a lease or something. So even for them also, the decision making would be further easier, that at what moment I should get my books of accounts clear for that given asset, right?
Okay.
Apart from that, if you go to the next slide, you can see that there is annual loss of around 323 productivity hours when exactly PDM is not in place. The machinery breakdowns can cost even large industrial firms around five and let's say $532,000 per hour. Apart from that, due to the breakdown, it increases the efforts of your people. So time is increasing, effort is increasing, money is increasing. So we need to optimize these resources. Time is the most precious element in the entire universe, I tell you. So I mean, everybody knows that, right? We can do anything, we can get money back, we can meet any loss, but we can't uh, bring the time back. So in that case, time, money, and efforts has to be synchronized to help that to have the better decision making. We can get into the predictive maintenance. If you go to the next slide, you'll find that the entire industry trend, if you see, it's continuously increasing. Earlier, the market was around having a CAGR of, let's say, around 37%. It is expected, sorry, 17%, and it is expected to have around 31% over a period of time. And to 2026, it's basically going to be a global PDM market size in $1 million would be around something like 30,000 across, right? So though there are different trending patterns, but I would like to focus more on the global front, how exactly it is really scaling up the business activities and operationalizing what exactly the business we're about to do. Yeah.
Can you just move to the next slide? And in the meantime, before we move on, Dr. Ravi, we have one question coming from Harshit Kumar. Hi, Harshit. So his question is, do Industry 4.0 concerns about data ownership when working with third-party providers?
It's a sub component of it. Basically, what exactly I can understand from his question is he's basically concerned about, let's say, when we talk about how we can leverage third-party solutions in place for a better data ownership, right, Harshit? You can just say, if you're not able to unmute you can just say yes or no. So you need to understand how exactly the third-party providers would be helping us further, and we can leverage them.
You're right.
Right. So when we talk about a revolution, right? Revolution is what exactly? It is the entire, let's say, every stakeholder of that business activity or industry activity is affecting, or let's say is participating in that particular revolution. So when it is about soft computing, you'll understand that soft computing cannot be achieved when there is no right data in place, because the computing would be done on what? The data side. So therefore, there's very much a concern to have appropriate mentor, let's say ownership, but at the same time, it is not only the final, what we can say component. This is one of the subcomponent, which is very important, rightly addressed by you as well. But yeah, the thing which I would like to tell is that there are n number of things which are even apart from that data ownership and the management aspect. And there, if I'll be going to one particular slide presentation where exactly you'll see, even if we talk about AI solutions, how large is the entire component structure. So one of the very important structure is going, or let's say the component would be a data per se, but yes, not the entire things.
Great, thanks. Hope, Harshit, that answers your question. You can just, okay, great, thank you. So Dr. Ravi, with this, if we can just move on to, what we were discussing is that, what are the benefits of predictive maintenance? And yeah, we can just move and
discuss that as well. So if you go to the particular next slide, you'll find that the kind of benefits which we achieve out of the predictive maintenance as an offering would be like, we can definitely put around 30% increase in the operational efficiency. You can tally that with your operating ratios. Basically, when we talk about the asset turnover ratios, when we talk about the current asset to current liabilities kind of ratios, and let's say the kind of long-term to short-term capital ratios, right? All these things can be reflected in a better way when we talk about implementation of PDM over there. Apart from that, when it comes to the operational challenges in terms of mechanical requirements, machinery requirements, in that case, 30% increase in the uptime would be there and 40% reduction in the maintenance cost would be there. So the business earns profit, and there are two centers in the business, like cost center and the profit center. So we are targeting both the sides. When I talk about operational efficiency, definitely it is targeting the margin as well. Apart from that, if I talk about the cost per se, the reduction would be helping again to have a better impact on your profitability of the firm. So in short, you can see that we can improvise quality, safety, and productivity of the entire process, the equipment, and obviously the entire organization as well.
Great.
And yes, if I talk about certain mechanisms, like there are multiple phases, or let's say the steps over there to work on predictive maintenance. There are so many different what we can say strategies, or right term would be different types of predictive maintenance which are available, or let's say types of maintenance strategies which are available. So the very first thing you can see is that we can have a basic maintenance and process in place. You can name it as per your choice. You can name it reactive, preventive, or predictive. What happens in the reactive is very much highlighted from this particular, image. So when there is a fire, okay, there is a firefighting team for that. It's a kind of a reactive maintenance for it. Okay, so we are not waiting for alerts. We just are identifying those insights where basically when we talk about public safety, these kind of maintenance aspects are there. Let's say reactive maintenance would be there if there is a fire broke out in the particular, it could be a forest or it could be a house, right? So this is a reactive maintenance. Predictive maintenance is a part where exactly we can get certain things beforehand. So I can predict that where could be a particular cyclonic situation, how exactly I should plan my travel. Accordingly, we can also predict that when exactly the larger equipment may go obsolete and what are the ways to fix it up. I'll discuss a scenario where exactly machines will be talking to machines. That kind of a simulation can also be worked out. And machines can tell the another machine that, hey, I need this particular stuff in place and of this much quantity. The other machine can reply, just wait, there is a particular fault over there. And uh, there is a kind of another scheduled maintenance which is going to be happening. So just try to manage with your resources. So see that kind of a scenario where exactly machines would be entirely talking to machines, and we can definitely use cognitive technologies there. Apart from that, the preventive one is if you go to a doctor, let me again stop here. Like if I go to a doctor, right, or what exactly doctor would do? The doctor would say, hey, Ravi, you are predicted with fever. You will be having a fever after 3 days, right? Does that make sense? Or let's say the doctor says, hey, currently you're having certain disorders and this is a right prescription. You take it and you be fit after some time, which is more
Yeah,
valuable.
I think that is the second one. I think he cannot say that, okay, you'll be having fever after 3 days.
Right. So in that case, we are very pretty sure that even seeing my reports, doctor can predict a number of diseases, right? In future, they can be, but it's not 100% sure that they will be. But at least at this juncture, if I'm facing certain problems and I get a solution for that, it really makes sense. So preventive side, or let's say the prescriptive side of it will be a better solution than the predictive one. And preventive is somewhat a kind of a that particular mechanism where exactly we would even want to work out in a manner that we can avoid a particular scenario to happen. We already know that it will happen from predictive. I would like to prevent it, and for that prevention I can have a prescription in place. So that prescription is, hey, you're going to have this scenario, just take all this particular inputs and the things will be all right for the given equipment. So there could be certain scenarios, the predictive, prescriptive, preventive, reactive, proactive, even multiple types and strategies and methodologies are in place. We'll discuss them at length.
Okay. So what is at the core of it? So when you talk about predictive, so is it about monitoring of something? Is it revolves around that? Because you also mentioned somewhere in between that condition monitoring is also one of the aspect. So if you can just talk a little bit about the conditioning monitoring aspects and how we can do that, and what are the resources available to achieve that.
Right. So when I said that, we can check the health of a asset, right? In the entire world, there are three different types of assets: physical assets, consumption assets, and let's say the real assets. So I'm not talking about, let's say, the consumption assets here. I'm not talking about the real assets. Let's talk about the physical assets, and we can definitely keep a check on their health. What exactly is the current state? Now, if you go to this link, I mean, the audience also can try this. So once you go to this link, especially when it comes to the one of the cloud platform, though we are platform agnostic, but to discuss the condition-based monitoring, I would like to take up this example. There are multiple vendors to it, like Microsoft has its own Azure Monitron, right, which is available. Let's get into this and let's see how exactly IoT Greengrass is working out. So maybe Dharmesh or let's say Neha, if you can go to this link and help audience understand what exactly IoT Greengrass can be useful for. So Ivana is asking for a kind of a quick share of this link in the chat.
Yes, I
Maybe
can.
we can
I've
achieve that.
I've just done that.
Sure.
So is it possible for Neha to open that
Yeah,
link?
yeah. I mean, she can open that. I mean, she just has to get into that particular URL. That's it. So here, what the audience can work out in their personal space is like they can understand with a very simple case study that how exactly AWS is scaling the IoT service for asset condition monitoring. So why exactly monitoring is required? Okay, so I have told it very clearly. If you don't monitor the refrigerator, which we have discussed in the previous example, it will be really difficult for us to maintain that when exactly there is a demand from the guest. Similarly, if you target, you're going to build, let's say, produce a number of quantity of items. In that case, if you are not even able to fix up your manufacturing aspects, especially talking about the industrial equipments, it will be a big failure. And also a status quo also would be at stake. Even if it is not a significant machine, the status quo is very significant for us. So if I cannot wait for simple issues which are affecting my entire supply. So in that case, what we can do is we can get into the case study, which is talking about, let's say, maximizing the wind turbine performance. So there is an end-to-end workout on the building a solution on the top of it, working on the IoT green gas services, which takes care of, let's say, end-to-end edge platforms. Every edge platform would be edge devices would be connected to it, and it will be taking the entire record of what exactly is the current state of that particular equipment. At the same time, it will give us the insights that where exactly things may go wrong. So just assume that if you are aware on certain things on cloud services, that if my machine learning model is going to be a failure, I can predict that beforehand when I have a particular monitor in place, or let's say kind of a cloud service in place, which can send me the alerts beforehand after seeing some kind of abnormalities in the data side, model side, and the concept side of it. So likewise, the entire architecture, if you see, especially collecting data from industrial equipment to the edge, everything has been, systematically placed here. You can also securely transport and ingest data to your AWS platform. I think most of us are already aware. MQTT basically for having the connectors for the protocols in terms of sending the data from your devices to, let's say, IoT core and even to the web applications and mobile applications. It is very easy here to maintain that protocol. So the MQTT brokers are also in place. Everything is really kind of available in terms of getting the better predictions and anomalies to be detected out of those particular machinery equipments. The processing of the data, detecting anomalies and triggering actions. That's what I said. When we talk about triggers, this is what exactly I would like to see when our device is working. So it could be any device. It could be a particular vehicle. It could be a particular forklift, right? It could be a turbine, anything. So I can just register my device on IoT Edge applications, and on the top of it, this IoT Green Gas framework would be running up all these sorts of mechanisms, like the time series analysis, the predictions, anomaly detections, and will give us a better insight on it. So if you can see, we are having the IoT analytics in place. Apart from that, we are having appropriate mechanisms to collect, process, and let's say manage the data sets, and then to have the analysis, and then finally get the deployment over there for the web application or the mobile applications.
Yeah. Yeah, sorry, please go ahead. Sorry.
So that would give us a kind of a understanding that how exactly I can make use of any cloud platform. Similarly, if Neha can go to that Azure Monitron, this would be entirely the platform again from Azure platform, and then they can definitely get into the scalable solutions. But I'll tell you certain problem statements, what exactly can go wrong at that moment.
Yeah, I think, talking about problem statements, I think, we can definitely leverage your experience over here, Dr. Ravi. So if I may ask you that, based in your personal experience, in your previous experiences, what are the challenges you faced while implementing these solutions, and what are the best ways to overcome those challenges? If you can just talk about some best ways to implement the AI-enabled PDM solutions, if you can just give us a brief around it.
Right. So let me give you some briefings on what exactly were the challenges which were being addressed. So when I was working for one of the project, especially in the farming equipments, what things we were planning is to have a better insight on the industrial equipments which they were using. And on the top of it, they should get alarming mechanism where exactly there could be a failure which can be sensed out of it.
Mhm.
Now the problem was their data science team was working in a different direction. When it comes to their cloud team, they were having a better cloud infrastructure and everything was managed from United States. So no problem was there. But when it comes to the deployment front, right, of those machine learning models, which they can utilize for a continuous deployment and for production, that was a big failure. What exactly the thing was, there was a missing link in terms of how exactly they can utilize model retrainings. They can utilize the frameworks where they can avoid such kind of glitches when they want to scale up the solution. The compatibility issues, the flexibility of the platform, and working on the data side, they were totally in silos. So those kind of scenarios were there, where exactly the manufacturing unit is perfect. Everything is looking great. But the thing is that there is some lack of integration between data team, data science team, and apart from that, the manufacturing team, and therefore things may go wrong. At the same time, we have to get into a proper analytics. At the same time, we have to collect the data also appropriately. At the same time, we should target the customers also with better product quality. So all those scenarios were exactly uh, helping us to understand what kind of solution we should pitch in. Apart from that, there is one more interesting case when we were addressing one of the aerospace giant, right? So they were working on identifying. I mean, they deployed one company to get a particular detail of all those particular, electrical wires which are in the farmlands of United Kingdom, and they used to have helicopters over there to take you know, the photography and then identify where there could be defect in the wires. So that was a costly affair. I was addressing some of the another challenges which were about the technology when they were working on deep learning side of it. But there was a team, like there were 17 teams, 17 industries they were targeting. So one of the team came and said that, hey, we are having this kind of issues, right? And the drone technology, if given these kind of tasks, no need for even getting those helicopters to even go for creating and let's say what we can say taking those imageries, and even then those images are being taken up just to take the health of that electrical wire, right? So see what kind of risk people are taking, what kind of investment they are making, and with the same time, at the same time, we have better drone technologies nowadays which can help us to have a better obstacle detection kind of mechanisms, or it could be identifying the faults in the wires. So we worked on GANs over there. GANs basically try to generate those false images also, fake images also, which exactly were not being seen earlier. So for example, I need to see how exactly a volcano can erupt, right? So what I can do is I can make use of certain GAN frameworks, especially when we talk about the computer vision side of it, and we can see how exactly volcano would be erupted and how exactly the lava would be falling out of it. So those kind of fake imaging technologies can also be in place to identify if you don't have a real-time data of fault wires. We can create those kind of we can generate those kind of data sets, and then we can run the machine learning algorithms. So similarly, we are working on so many geospatial side also. I mean, with customers when we're working on geospatial domain. So in geospatial domain, we are working with, let's say, NDVI prediction and let's say classification, how exactly we can check the health of the geographies and where exactly that particular geography would be of a particular, let's say the particular geography would be having a poor vegetation. The other location can have a better vegetation. How exactly we can classify those? So those were the particular challenges which we're confronting regularly. And nowadays also the challenges which we face are more in terms of the equipment failures and how exactly the vendors would be right vendors would be there for IoT devices. How exactly they could be having the scalable solution in place, especially when it comes to machine learning side of it, so that makes the entire task easy. Now, to address this, there are so many ways to do this. So first of all, we should understand that even if I want to apply AI model or let's say machine learning model, before that I need to understand what exactly is my predictive maintenance stage. So people go for let's say data maturity assessment. artificial intelligence maturity assessment, I would recommend that we should also understand what exactly is our predictive maintenance maturity state. So it depends on, let's say, firms to firms, like Gartner has its own scaling, right? Some other players may have their own scaling for it. But yeah, what we can identify those stages. Companies can assess themselves on the capability side of it, in terms of processes, in terms of content, the performance measurement aspects, what are the metrics in place. Apart from that, the infrastructure in terms of IT, that is information technology side of it, and the organization acceptance and the vision for that. So in short, what we can do is we can go for the very first level of maturity if we just work on visual inspections. I have an instrument inspection framework. That would be the second stage. Third stage would be, again, we can go to the previous slide, please. The real-time condition monitoring. So there you can see that with the advent of cloud, it has become easy, right? And PDM 4.0 is nothing else, but we are talking about the highly optimized solutions. That's what exactly this is right now. Yep. So here we can see in the last stage, especially the highly optimized stage, we're talking about continuous inspections. Sensor and other data sets are being utilized. Digital recording is there for the processes. If it comes to content, we have a digital condition data. We have a what we can say digital environment data sets. Maintenance history is available. Apart from that, in terms of performance measurement, automated frameworks should be there for norm verifications. Digital trend analytics should be in place. Advanced decision support mechanism has to be there, the DSS, and similarly with the IT and the organizational structure.
So Dr. Ravi, we just have one question coming up from Harshit. So he's asking that talking about data in Industry 4.0 world, what are your views in terms of security of data?
So instead of giving my views, let me give you the global understanding on it. So almost 31% of the stake of the investments, or let's say the major companies which they are investing, is in the cyber security and data security space. So there is a huge scope. Let's say if I have $100 in my hand, I'll spend almost $30 to $31 in data security and let's say cyber security aspects if I'm using AI, right? So Arshit, you can understand if you are going with an AI solution, what exactly would be the global ask for it. At the same time, it means that there is something wrong in there, right? It means companies are regularly facing those kind of challenges and threats. So definitely, yes, there is a huge scope in terms of mitigating those particular challenges. And also, as a solution provider, as a particular manufacturing unit also, there is a huge responsibility and accountability from our side also, how exactly we can have right governance in place to overcome these kind of attacks. And there is obviously, similarly, if I talk about predictive maintenance, there should be the assessment of what exactly is your current state of artificial intelligence. So I said that this particular webinar is focusing more on MLOps side, and artificial intelligence is going to be the entire infrastructure by which you are going to automate the entire predictive maintenance cycle. So it is very much imperative for us also to optimize our AI assessment, and that AI assessment will pave us a way forward how we can even make it best in class scope for our maturity of predictive maintenance applications. We can go to the next slide to see how exactly Gartner placed all those particular frameworks in terms of AI strategy and maturity. So you can clearly see that we have got level 1 of awareness. We have got the level 2 as an active level, where exactly it's more companies are more focusing on AI exploration, primarily in the framework of data science. Level 3 is companies in a state of operational aspects, where exactly AI is basically helping business, adding value, for instance, and let's say streamlining the process or even coming up with, let's say, new services or products. The company would be at a level 4 when it is systemic, which is basically that it's widely employed in the entire organization to transfer business activity, and it is entirely transformational if AI is in their DNA. So it means that we are working on two ways. We have got different models. Therefore, it's a comparative approach that different models talk about foundational aspect of it, approaching aspect of it, the aspirational aspect, and maturity aspect. So level 5 is the utmost one, which we can use from here, and level 4 of your predictive maintenance. If you have that combination, you are leader in the market. If you are around level 3, I would say that you are growing. And if you are in the very initial levels, I would say that in the PDM or AI, you are in the nascent stage. Hope that makes sense.
Yes, thank you, Dr. Ravi. And Dr. Ravi, we were talking about AI maturity, and we spoke a lot about MLOps. So just for the for the understanding of audience, if we can just talk a little bit about what is basic MLOps and how it is different from traditional ML systems. And second question, the very first basic thing, what exactly is MLOps and how it is different from the traditional ML systems. And then second is that how MLOps can scale up PDM models and optimize them further. So if we can just talk a little bit about that.
For sure, Dharmesh. So MLOps approach is very much simple here. Like earlier, what we used to have is the traditional ML cycle. So when we talk about the traditional ML cycle, it was having certain issues with deployment, especially when it comes to monitoring. It was very lethargic over there. When it comes to the lifecycle management of the machine learning applications, again, it was a challenge over there to confront. Model governance was another, big challenge when we talk about the traditional ML cycles. With the advent of MLOps approach, it has increased the entire productivity of the data scientists and let's say engineers, machine learning engineers. The ML systems are now working with the highly optimized level with a better scalability now with a fault tolerant mechanism. When I say fault tolerant mechanism, it means that we are having a particular system in place which is not affected by, let's say, global failures of my clusters or let's say my nodes out there, right? So those infrastructural aspects are being covered up, tracking the model, not only data, but tracking the different models, auto ML features, working on, let's say, 100% automation in terms of model governance. These are the core aspects of MLOps. When I say model governance, here explainability of the model is very important. So explainable AI and all these things have been evolved with the MLOps approach, and that is continuously growing. If you see the entire, if you go to the next slide and see what exactly is the market about MLOps as per the January 2021 event.
Oh wow!
You will
This
see that
is
the entire
this is
data.
Yeah, this is the vast ocean of providers, we are looking at. I think, you have, I can't even see. I mean, there are so many. The very important question here, Dr. Ravi, is that, what is the best way and how we can select the right vendor for any kind of, sensors or other AI systems. And when we, anyways talk about, AI and sensors, it obviously boils down to and connects to the right IoT and edge platforms. So how exactly we can narrow down on the right vendor?
Exactly. So for addressing this particular thing, I think you can see that the entire ocean is there for every basic component of your MLOps architecture. Let's say the continuous deployment has multiple phases to, even working on the data management side, model governance and everything. For every unit, you can see there are at least 5 to 10 different players. Now, what exactly we can do out there is we have certain metrics to play. Okay, can we go to the next slide and see how exactly we can help companies to come out of those kind of scenarios? So we are actually working with certified vendors. We have got the partnership with, let's say, top hardware and sensor providers in this market. We talk about the platform, so we definitely have our own platform. We are having the full-fledged, let's say, platform for end-to-end build-up on the predictive maintenance solutions. If we talk about the cloud solutions, we can definitely guarantee the highly optimized cloud solution with the cost-effective measures, like Ivana is mentioning, how exactly we can leverage preventive along with the preventive maintenance program, along with the predictive maintenance which can be a better option for bringing up the ROI upfront. So that kind of challenges can be easily met. We definitely have the expert team which takes care of how exactly the technology, the hardware, software, and let's say the kind of infrastructural from the cloud part setup could be worked out. Even working out on, let's say, the data science operations, the team is efficient enough to work on those particular scenarios and get the highly valued business outcomes.
So, Dr. Ravi, if you can just talk, in detail about Compunal's approach to address that problem. specifically in the modernized MLOps practice, how exactly company will contribute as a subject matter expert, if you can shed some light on that as well.
Definitely, we have our own way of working on the best practices. So what do we do is we have got a conscious approach. Artificial intelligence, if I talk about, right, that is the uh, very narrow thing to work upon. Why I'm saying it is a narrow thing, because it itself says that it is something artificial, which is having a kind of a matter as an ingredient to it. When the human conscience, let's say the consciousness, is gets attached to the artificial intelligence, it really becomes a kind of a powerful mechanism. So therein, the team which exactly works out at a communal, they are very much pro in terms of identifying the right strategies, because they are very much directed towards the end user. They're not focusing only on technology front. They're not only focusing on, let's say, the investment into the cloud setup. They're focusing that how exactly customer experience could be improvised, how better ROI can be worked out. So right from starting the review, right from the very start phase, let's say review of the business case, then identifying the data sets, and getting the value of the time, and then even preparing data modeling part, deployment part, we are having best practices over there. We'll share that particular, the entire stuff on the best principles of conscious AI with the team very shortly. We are also working on certain articles around conscious AI, the utility of that, and maybe the attendees can also get a better idea how exactly the human consciousness along with artificial intelligence can be a right, what we can say, component than simply working on artificial intelligence, right? Coming to the next slide, what we can do is, here comes, let's say, some of the exemplaries, like how exactly we try to build up the solutions. So we got let's say we start working out with a centralized data lake systems. Data is basically in silos. So why not to keep it in a such a way that we can have structured, semi-structured, unstructured kind of data sets all together. And then whatever the whatever the particular unit want to use that database, we can allocate appropriate rights to them. So we work on data privacy, we work on data literacy side of it. Apart from that, you can see the entire governance of the machine learning operations to scale up your PDM applications would come up in such a way that we can have the IoT devices, the sensor, the observations through cameras, any manual and the other data sources we can directly ingest. Apart from that, there is a pipeline which is built up for data pre-processing, feature engineering, and regular experimentation also. In the experimentation, it's all available at different cloud platforms. What is different here is when it comes to experimentation, we are not just only iterating. We are identifying the loopholes in the previous researches with the appropriate research gap. And then on the basis of that, we conclude that what should be the right measure, right experiment. On the basis of that, we build the models. So in the experiment itself, we take such kind of measures, which exactly would be not very, what we can say, iterative. They are more than consciously designed and articulated in such a way that the model failure would be a kind of a very difficult thing to happen. And then we containerize it, we post it on the different platforms. Retraining triggers are also being capitalized here in terms of making the solutions even better. And we have got the API gateways to even host the web applications, mobile applications for the client per user. Right.
So do we have any applications which we can show, maybe some?
Definitely, Neha, if we can go to the next few slides, we can showcase that while working on, let's say, certain platforms, what we do offer is we definitely talk about the data pipelines. We have got the features in place, the feature store, offline features, and let's say online features can be worked out. Apart from that, the pipelines, when you talk about this pipeline would be the model pipelines which we can build up. AutoML approaches can be there. Backend, there would be a cloud platform depending on the client scenarios, and appropriate analytics with what we can say the explainable AI framework. So those dashboards we can definitely provide to the clients for their per user. Similarly, we have certain use cases which we have worked out in the recent past, and we have a small video to play. So maybe if you can, yeah. Elena is basically nothing else but the AI studio which we have, which is continuously working in the research field for artificial intelligence and machine learning. And our major forte is basically MLOps to scale up the business solutions. So here you can see there is a web application which was just a kind of a GUI platform which we created. You will realize that the data sets from the, let's say, the equipments were identified and the vibration, pressure, speed, etc. Everything was being detailed out there, and the dashboard was maintained to have better visualization of all the minute aspects, the significant factors which impact the entire failure of that equipment, anomalies which can be tracked, and in the end, the prediction also. So the solar panels were having multiple aspects to cover up, right? So in this way, you cannot see that, but what we have done is we have worked on end-to-end approach on machine learning operations, right from the explainable AI, model governance, concept drifts, data drift checks, and after that we have selected, let's say, the final models which could be sent to production. So there are multiple ways by which we can, conceptualize the solutions for our clients, where exactly we can make use of the cloud platforms, the sensor technologies, the hardware aspects of getting the details from the machines, and then making the best-in-class predictions with highest accuracies.
Dr. Ravi, in the best interest of the time, we are almost there. So if we can, if you can just talk about, the technology behind, the predictive maintenance. If you can just talk about that a little bit and the solution approach, I think that will really help us, help the audience to understand it better.
Exactly. So I already discussed that, like when we talk about the technologies for predictive maintenance, we'll have to identify a right solution in terms of getting the sensor technologies when it comes to Industry 4.0, understanding how we can avoid all those traditional mechanisms of physical verifications and manual interventions, and can shift to the automated frameworks. Apart from that, what we can also do is we should understand that there is a huge paucity in terms of right big data solutions. So those big data solutions, let's say if I talk about Apache NiFi, let's say Kafka frameworks, that basically is the need of the hour, that how exactly we can articulate all those particular infrastructures. We can bring in right capability in place so that we can optimize the entire anomaly detection mechanism, or let's say the preventive mechanism for my machine well in advance, right? For that, big data technologies, working on the sensor technologies, working on majorly on machine learning side of it, and MLOps would be definitely the right set of applications to work upon. And yeah, if you can go to the next slide. Again, the next one. So this in a nutshell, we can see that if you are working on these technologies, at least we can make it sure that we are having right system in place, which helps us to further automate our applications when we talk about the predictive maintenance solutions with better scalability. It will double the impact. It will, double the impact of your operations. For example, if I want to, if I'm, hoping for a particular product of X quality, right? It will improvise my quality to almost that way that it can be really increasing the customer experience while that particular the product is being delivered to the customer, because right from this buying of that particular raw material to conversion of the finished good, everything is being tracked in the entire supply chain. So that supply chain optimization, energy optimization in your company, working on, let's say, safety of your manufacturing unit, and let's say the failure of equipment can be tracked very easily. So that's where these technologies would be helping us further to have a better solution in terms of predictive maintenance.
And very quickly, Dr. Ravi, we spoke about predictive maintenance. So the most important thing, and to conclude, if we can just talk about that, which all industries you think, this PDM, predictive maintenance can be applied. And if you can quickly talk about some of the use cases from different industries, I think that will really help the audience.
For sure, Dharmesh. So what we can do is we can go to the slide which talks about, let's say, what are the kind of major industries which we can apply the predictive maintenance upon. For example, can you imagine there is a service industry and it requires predictive maintenance? What's your take on that, Dharmesh? So if it's a banking system, what do you think? Will it require predictive maintenance?
Yes, definitely.
Right. It has got walls, it has got ATM machines, it has got vehicles and everything.
Correct.
So
Correct.
you can see that, when we talk about keeping a track on the cash, keeping a particular, track on the machine, ATM machine, definitely all these mechanisms could be in place, even serving in service sector. Manufacturing industry, already we talked about industrial equipments, food and beverage industry to have biochemical reactions. We can even work on those levels where exactly we have biosensors in place, right? Instead of IoT sensors. In oil and gas and refineries, we can definitely talk about industrial failures of those particular machines and refineries, vehicle part automation, and then working on prediction of those failures can also be a part of it. Electrical grids, working on server rooms, let's say household, everywhere we can see that the predictive maintenance solutions is in place, right?
That is great. And if you can just quickly, go through some quick use cases, briefly, Dr. Ravi.
Definitely, yes. So what we can do is we can go to certain use cases which talks about how exactly we can have a better usability of, or let's say, infrastructure for your predictive maintenance application with MLOps as a backend. And at the same time, it is highly optimized and automated one. So let's take a particular for use case number one, which basically is talking about, let's say, can I have the AI basically in the manufacturing domain? So now everything, right, from the process control to working on, let's say, product quality to, let's say, energy optimization. And in the next slides, you'll find that we can even help the industry to have a better equipment failure predictions. And all these things can be, talked out properly when we talk about usage of AI in manufacturing. So if you go to the next slide, Neha. Yeah. So public safety, the safety at factory premise, all these things are very much concern for everybody. If I talk about demand planning, if I talk about production and inventory management. So, everybody's aware like how exactly we work on economic order quantities, right? But not only economic order quantity, the pilferage of that quantity, or let's say the inventory, the selection of the inventory to mechanism of how exactly I can have the ABC kind of a costing for that given inventory can be monitored well and can have a better planning for inventory management as a whole. So this kind of things can be worked out at the manufacturing unit. If I go to the next use case, let's take an example of automobile. So you can see that we have got a particular use case objective as like we want to forecast, let's say, when exactly that entire vehicle would fail, or let's say a part of that vehicle would fail. What is the objective here? To enhance the life of that particular vehicle and to have a right replacement strategy, servicing strategy. So we can have a replacement or a service or a maintenance of that particular vehicle. So see the solution over there. It is starting with, let's say, collection of those inputs, again, sensor technologies, working on reinforcement learning kind of mechanisms, the cloud gateways, which exactly helping us to host the applications on the cloud premise to the web application framework, and also processing the information from data lakes to powerful visualizations. So those things are becoming pretty easier. In 6 to 7 steps, we can see how exactly we can, have the entire flow chart in place, and right tools, technologies can be integrated further to have a better prediction in terms of a failure of that equipment. Likewise, we'll be having multiple such use cases, and the same can be, can be given to the client, the attendees over there, and we can share the benefits, the outcomes, the different use cases which we used to work upon, right, on different parts of the industries.
That's great. So, Dr. Ravi, if we can just have conclusion statement from you. We spoke about a couple of use cases. If you can just summarize the whole thing for once for us, I think that will really help. And because it's in the best interest of the time now.
For sure. So I think the entire conclusion is like, though there are so many vendors, there are so many partners, there are so many companies in place to offer the solutions. The right way is to keep the solution scalable. At the same time, it has to be simple. So your team of data scientists, team of data engineers, team of machine learning engineers, or let's say even your hardware team and let's say the technical mechanical team, they can understand it in a better way and they can cooperate all together. So keep it simple and scalable would be the final conclusion statement. And coming to the next thing, we can also have the solutions from the digital twins technologies. Metaverse is coming up. People can, observe how exactly the things would go over there. They can, take that virtual feel of it. There are so many mechanisms which companies are working upon. Robotics is coming up. So I think we can discuss all those agendas in coming webinars. And till that time, I think this was a session which was basically to give a high level understanding in terms of the PDM applications.
Thank you, Dr. Ravi. That was really interesting, and I would like to, pass it on to the audience. If anybody has any questions, please feel free to post them in the chat box. We would love to take those questions. And in the meantime, if by the time we receive any questions, I would like, that surprise announcement. I would like to share that with all the audience. That if we are offering free 1-hour consulting session with our subject matter experts, along with, of course, Dr. Ravi and along with his team, to talk about any use cases you may be working on. We can definitely work on that. So Ivana has shared one question. I think
the initial investment costs for predictive maintenance are high and require infra heavy setup, tech specialist, experienced personnel for data analytics. In your views, how much predictive maintenance can average the cost of preventative maintenance program, which being a low on investment approach? So definitely yes, Ivana, there are open sources available for every aspect. So I mean, if you want to understand that I want to reduce the investment into it, I need to have a team which can work out end to end for these kind of projects. And without cloud technologies, that can be achievable. The only thing is that you should have a right team with right technology, the programmatical access, the hardware understanding, sensor understanding, and open source are available, which can be a very optimized solutions, which can be scalable as well. But that will take some efforts. Time will be customized, I mean, as per the use case and everything which you want to, work around. But when it comes to money, that also is fine. But when it comes to efforts will be more, right, in these cases. So to work on a better optimization, there has to be a right balance of the team, the infrastructure utilization of maybe the cloud platform, open premises, whatever on premises solutions. And therefore, we are there to help you out. Maybe if we can discuss this in our meeting, which we can, block the calendar upon,
yes,
we can definitely help you out further.
Yeah. Neha, if you can just paste the link of HubSpot or Calendly where audience can block calendars for a 1-hour workshop, consultation workshop.
Yes,
I think.
sure.
Any other questions? So we have the HubSpot link for Dr. Ravi in the chat box. You can please use that to book slots in the coming days, and we would love to have a one-on-one session with you for almost for an hour, where we can talk about various aspects about your current state of affairs and how we can contribute to that. We can definitely have a consulting session. Any additional questions, anyone?
So I think Dharmesh, it's from the question now can be from our side. How was the session? Really, people enjoyed it. If yes, then let us know. You can also share your feedback over there. Maybe in the chat also, if you can mention how was the session, you really enjoyed it or not. Accordingly, we can plan it.
Any feedback forms we have in the event of 5G, PDM is set to rise. So Ivana just mentioned one more thing, if you can see in the chat.
Sure. So with the advent of 5G, PDM is set to rise. Definitely yes. Reason is very simple. Better, what we can say, no time lags, almost real time now. Now earlier we were having some N-1 day kind of workarounds. Now it's more real time scenarios we can deal with. Because the streaming would be, let's say, Kinesis streaming and all these things would be real, really would be picking up further. And tracking would be perfect. Even reporting would be better. That's why, Ivana, it would be great. Thanks everybody for this and for being patient listeners. And also would be great if you can contribute in terms of asking questions, or maybe you can put forward your particular insights upon the same. Yeah.
Thank you, Dr. Ravi, for the valuable
so
insights and the presentation which you have worked on. And yes, definitely we are looking forward to more such sessions. And you already gave us a hint that okay, these are the topics which you will be covering maybe in coming days. So looking forward to it. And thank you, everyone. Thanks for your time.
Thanks again, everyone. Take care. Bye bye.
And we look forward to connect with you.
We're happy to share it to all. Thank you.
Thank you, everyone.
Thank you, everyone.
Thank you.